we're making this connection. In fact, we're kind of finishing the connection that we started on Wednesday when we talked about how logarithms and exponents were connected to each other, right? So you think about the exponential equations that we've done. There were two ways of solving them, right? What were the two ways of solving exponential equations? Yeah, if I have common bases, right? If I had common bases. So let's say, for instance, we had 3 to the x was equal to 9, like that. We could change this base to be a what? 3 squared. So we had this common base, and this is a really, really simple problem. But the method here was, if I had the same bases, I could do what? I could drop the bases. And of course, I could set what was left equal to each other. In this case, there was no solving. It was your answer. But sometimes we have a problem, like 3 to the x power equals 31. And what's the difference between this problem and that problem? Yeah, I can't make 31 have a base of 3. Because 3 times 3 is 9, times 3 is 27, times 3, nope, I went right past 31. So I can't make them have the same base. So what did we say you do? You would rewrite it as a logarithm. So those were our two methods. If the bases were the same, you drop the bases. If you couldn't make the bases the same, rewrite it as a logarithm. Okay, today we're talking about logarithmic equations. You know how you know that it's a logarithmic equation? It's going to say the word log. Okay? Impossible to miss. It'll literally say log. Guess how many ways you can solve logarithmic equations? 2. Yep. 2 ways. And they're identical to these. This one, the bases were the same, so we dropped the what? Bases. Guess how you can do one of the logarithms? You're going to have what on both sides? What will the bases be, though, in a logarithmic equation? They'll say log. They might say log of or log base 2. They'll be the same. So if you have logs on both sides, guess what you can do? You can drop the logs. Just like we could drop the bases. But what if you don't have logs on both sides? What if you have log on one side and you have a number on the other side? How do you think you're going to be able to solve those? Nah. How do we solve exponential equations that we couldn't make the bases the same? Exactly. Just like we turn these into logarithms, when I have log equals a number, I'm going to turn those into what? Exponential. So that's it. That's what we're doing today. Okay? It's really simple because you understand, hopefully, now the connection between logarithms and exponents. We've solved both methods of exponents, so these are just as easy. Okay? So here's the notes, and it's the homework. So if you feel 100% with where we're at on these, at any point you can flip the paper over and you can start working on the assignment. Yeah, it's going to be the back of this worksheet. So the front's the notes. We're going to do all the examples. So if you're struggling or confused about any of them, we'll go through it. But the back is the homework. Okay? Should be an easy day for you. And that will conclude the connection that we've been talking about with logarithms and exponential equations. All right, so there it is. Here's our two methods. If it's log equals log, so if I have log on both sides, what do? I drop the logs. But if it's log equals a number, what am I going to do? I'm going to turn it into an exponent, and then that will give me, the ability to solve. Now listen, sometimes with logarithmic equations, they have what they call expanded equations, where they have some logs that are separate from each other and you have to put them together, when that happens, sometimes your answers are what we call extraneous. But we've already condensed them because we didn't talk about the properties of logarithms, and we're not going to. It's not one of our standards. Most of you guys are probably going to go into pre-cal next year, and you will talk about the properties of logarithms, okay? Because exponential equations, logarithmic equations are an important part of pre-calculus. In that class, you will expand and condense logarithms, so you will have more extraneous solutions. The way we have them written here, there's not many, okay? In fact, of all the notes and all the homework, you're only gonna run across one answer that does not work when you plug it back in, okay? So we're gonna start with B, okay? Look at B. What do you notice about B? You got log on both sides, right? So when we have log on both sides, what do? We literally drop them. They're gone. And that will allow us to take the 4x minus 2 and set it equal to x plus 7. And now we're just solving a simple equation. How do you do that? Yep, we're going to get our variables together and then isolate it, right? So personally, which one would I move, 4x or x? So I'm going to subtract that x. What is 4x minus x? So 3x minus 2 equals 7. And now we're just solving a pretty simple equation, right? I've done this a million times. To get x alone, first thing we move is the 2. We add it. What's 7 plus 2? And then last we divide by 3. So 9 divided by 3 equals 3. Now, listen, I'm not going to do this with every problem just because I know that you guys get this and it's pretty simple. But if this problem were not condensed, if it were expanded, you would go back to the original problem and you would simply plug the value that you found for x in and see if it really works or if it gives you what we would call an extraneous solution. So in this case, you would go to your calculator only. You don't have to even write it. You would go to your calculator, because this is just log. It's not log base anything special. It's just log base 10. Couldn't I use the calculator button right on the front of my screen? The log button. So do log, and then do 4 times 3 minus 2. You type that in and push equals, it'll give you an answer. What'd you get? You got 1, right? And then you go to the other side and you do the same thing. Log of 3 plus 7. What do you get? So does 1 equal 1? So therefore, 3 is my solution. It is not extraneous. Okay? We just plugged it in. Like I told you, we're not going to run into many extraneous solutions because these logarithmic equations are already together. They're already what we would call condensed. Okay? Now, go over to A now. I wanted to save this one to second because this is obviously the one that takes just a little more thought, not a lot more. But notice how this is different than B. Does it have log on both sides? Then I can't just drop off the log. Okay? You can't do that unless it's on both sides. So what do I do instead? If I can't drop off the logs, we rewrite it as a exponent. And what was the rule? We learned about that on Wednesday. The base of your log becomes the base of your exponent. What is the base of my log here? So 4 becomes the base of my exponent. And then remember, we do the loop. 4 to what power? The second power equals what? What's the argument of that original log?
2x plus 6.
That's what it equals then. 4 squared equals 2x plus 6. And then we're just solving it however we need to solve it. What is 4 squared? 16 equals 2x plus 6. Next. Yep, we're going to subtract that 6. What's 16 minus 6? So 10 equals 2 times x. And then, of course, last we're going to divide by 2. So x equals 5. Feel free to go back and plug it into your calculator to make sure that the log base 4 of 2 times 5 plus 6 does in fact equal 2. I'm here to tell you it does. Okay? Definitely does. I'm going to skip C and D just for a minute, and I want to jump down to the E, okay? Is everybody ready? E has a little trick to it. Is it log equals log, or is it log equals a number? It's log equals a number. So how are we going to solve it? We're going to change it to exponential. So do y'all see the trick on this one? That you just have to remember one thing. When there is no base, it's understood to be base 10. So when I go write this as an exponent, the base of my log is 10. So 10 becomes the base of my the base of my exponent. And then we do the loop. 10 to what power? The second equals what? That whole thing, right? 50x over x minus 1. So guys, what is 10 squared? So 100 equals 50x over x minus 1. And there's a couple of good ways to solve this at this point. Yeah. Some people will make 100 a fraction, and they'll cross multiply. That's perfect. Some people, and again, I don't care which method you use, some people will say, hey, if I'm dividing by x minus 1, what can I do to get rid of that? I can multiply by x minus 1, which really ends up doing the same thing. What will happen on the right side with those x minus 1s? They'll cancel. So on the left side, what is 100 times x? And what's 100 times negative 1? Negative 100. On the right side, we already said those x minus 1s cancel, so 50x drops down. And now you're just solving a problem.
I think we've just been more like
why I made that base 10?
Yeah.
Because remember, anytime you have a log with no base written, it's understood to be log base 10. If they wanted this base to be anything else other than 10, they have to put it there. So since they left it blank, it's understood to be log base 10. Okay? Common log, when there's no base, is base 10. Common log, when there's no base, is base 10. Now, solving this problem, you got a couple of options again. What do y'all want to do? I know what I would do, but what would y'all do to solve this? Okay, so if I'm going to move the 100x, I subtract it, correct? So on the left side, it's gone. And what's left? Negative 100. And on the right side, what's 50x minus 100x? And then to move that negative 50 away from x, we divide by negative 50. What's negative 100 divided by negative 50? Positive 2. X equals positive 2. And again, like I said with the last problem, I promise you, if you go plug that back in, it will work. It's not extraneous. Okay? We're just going to save some time and not do it. So, I feel like that gets you guys pretty well covered. The only reason I was saving C and D for last is because the process of solving after you've used what we've talked about today. So the easy part of C is this. Is this log equals log or log equals a number? So we're going to drop our logs. So what are we left with on the left side? And what are we left with on the right side? So here's the only difference between this problem and B. Can I just solve for x now? Can I just get x alone? No. I got to do what? Because you have an x squared and an x. I got to load up a side, and I got to factor. So I'm going to bring the 12 over. How? Subtract it. I know y'all probably didn't love factoring, but as you guys can tell, it just keeps sneaking back, right? Are y'all excited about this now? Are you thinking, oh, that means we're not going to have to practice? All right, so we're going to factor this trinomial into what? Two binomials. So here we go. What will multiply to get x squared? X and x. What will multiply to get a negative? Positive and a negative. Y'all remember all this, right? So that means they're working against each other. So we're looking for the two numbers that multiply to get 12, but have a difference of 4. 6 and 2. It's got to be 6 and 2. Everybody agree? Last thing, negative dominated the middle. So negative has to go with my bigger number. Which one was bigger, 6 or 2? So negative 6, positive 2. Now, once we have these factors, what did we say we do to solve? Set them equal to 0. So this one I will subtract 2, so negative 2. This one I will add 6, so positive 6. So sure enough, my two solutions, and they both work. Go try them. Feel free to try them. Your two solutions were negative 2 and positive 6. Y'all will learn this in pre-cal. The whole extraneous thing, I've said the words expanding and condensing. What happened sometimes in a problem like this, they started with log of x times the log of x minus 4. And then, of course, you combine those by multiplying, and then that is what causes sometimes there to be extraneous solutions. Anyways, let's move on. D has one last trick to it. And we ran into this yesterday. What did we have to do first on several equations that y'all had for homework last night? We had to isolate the exponential expression, correct? Sometimes in these logarithmic equations, we also have to isolate the logarithmic expression. So that means the log base of your argument. Well, what's outside of that log base argument? Plus 2. So are we ready to solve this problem yet? Not until we move that. So how do I move that plus 2? So I'm going to subtract that, and that will leave me with log base 2 of x squared plus 2x equals 3. Now, how do we solve this logarithmic equation? Is it log equals log? So we don't drop the logs. So I have to write it as a what? What's the base of my log? So 2 becomes the base of my exponent. And then I loop it, right? 2 to what power? 2 to the third power equals what? X squared plus 2x. And then that puts us right back on the same track we were just a second ago. What is 2 cubed? Am I going to leave that 8 alone on one side and solve for x? No, I got to move the 8 over. How? By subtracting it. And I got to solve by, Aubrey said it a second ago, got to solve by factoring. Solve by factoring. So here we go. One last time. Two binomials. What did y'all say multiplies to get x squared? What did you say happens to multiply to get negative? Positive and negative. So we're looking for the two numbers that multiply to get 8, have a difference of 2. So you're exactly right, Eugene. 4 and 2. Last thing. If positive dominated the middle, it had to go with 4. And that left the 2 with the minus. So here they are. X plus 4 equals 0. So x equals negative 4, correct? And x minus 2 equals 0. So x equals positive 2. And again, feel free to go try them. They both work. So neither are extraneous. Okay? Questions? Anybody? So as I told you already, what's your homework?
The other side.
The other side. And what I didn't tell you is I'm going to go ahead and tell you your answers. So you can check them as you do them. If you've already done them, you can check them to make sure you got them right. So there they are. Number 8 is the only one that you're going to solve that one of the values that you will get won't work.
Why?
What?
0.
Yeah.
0.
We'll let everybody else figure that out. You just thanks. Alright, so there you have 8 problems. Anybody have any questions for me? Okay, so as you come across one that you might not understand, I'm here to help you. Does everybody feel good about this? You see that connection between exponential and logarithmic? We've exploited that to the best of our ability. Hopefully y'all understand it.